Okay. Hi, I'm a postdoc in the Woodrow Wilson School at Princeton University, and I'll be presenting you some insights on this project that I'm working with my co-authors on the relationship between nightlight and socioeconomic variables at high spatial resolution. So first, what is nightlight? Nightlight is remotely sensed anthropogenic nighttime luminosity. It's very popular in economics and other fields to use nightlight data as proxy for population or economic activity or other socioeconomic variables, particularly in regions of the world where data quality is a big issue or data might not even exist at all. And the big advantage of nightlight data is that it is consistently collected around the entire world because it's measured through satellites. Unlike most other socioeconomic variables like population, which is usually collected through a census and provided at some admin level, and there's huge differences across different regions of the world. So if we compare, yes, that works. If you compare nightlight and population, it's really easy to see that there is this clear spatial relationship on a global level. What we don't really know yet is how much of that relationship is actually due to some inherent pattern, or how much is just this concept that I want to call social use of space, that almost any social variable, if you plot it on a map, will pretty much look the same. And it's kind of hard to figure out how much of that relationship is actually causal. So what we are doing is we are having a case study on Austria, where we have this really great Austrian regional statistical grid, which is a high quality data set on population, employment, buildings, etc., at a resolution of 250 by 250 meters. So we're using this to kind of look in more detail at this data. So I'm just going to show you stuff on population right now to the time. So here's population for 2001 in Austria at this high resolution. And again, if we compare that to nightlight in the same year, we see a clear relationship that is obvious to the naked eye. But then when we plot that as a scatter plot comparing nightlight to the log of population, we still see this relationship, but it's actually not as strong as we might think from looking at the maps. So let's kind of go into more detail here, zooming it into one kind of smallish city in Austria. This is the nightlight grid. And then we can overlay that with the regional statistical grid, which is much finer. So let's zoom in so we can see something. So the red cell is one nightlight cell, and what we saw before in the scatter plot was the value of that nightlight cell plotted against the population of the sum of all these tiny cells that fall into that cell. But when you think about nightlight, you might sometimes have situations where you have a big parking lot, for example, that services a building that's close by, but might not actually fall into that same cell anymore. So what's happening kind of around that cell might still matter for what kind of light we have in this cell. So we also compare nightlight to not just the population in the cell, but also within a radius, and then use different kind of sizes of radius to see what's happening. So this is kind of providing these scatter plots here for nightlight versus the aggregated population in a 1 kilometer radius, 2.5 kilometers, 5, 7.5, and 10. So we see there was an improvement in this fit, but at some point it actually got worse again. So let's go back and see how it gets better again. And we find actually that at around 2.5 kilometer radius, we find the best fit between these different types of data, particularly again, if you compare to just the cell level itself. So we can also compare not just the aggregated population with the nightlight in the cell, but we can also compare the aggregated nightlight with the aggregated population to get kind of the idea of what happens when we have a coarser resolution of the data. And when we do that, we actually find a very strong fit. This would be, for example, for 10 kilometers. So using coarser resolutions might sometimes actually help to improve this relationship between nightlight and variables like population. So kind of summarizing our preliminary results here, we find that high resolution nightlight correlates best with population in about a radius of 2.5 kilometers. Aggregated nightlight and aggregated population and other socioeconomic data display a really strong relationship. And then from kind of more, I didn't show these details, but more our high resolution analysis, we find the spatial correlation between nightlight and all kinds of socioeconomic variables is really strong, but the temporal correlation between changes in these variables is actually fairly weak. Pretty much most of the socioeconomic variables in our data set explain about the same amount of variation in the nightlight data. So we do seem to kind of pick up a little bit of the signal of social use of space and not having a very specific relationship between these variables and nightlight. But we do also find that some uses of social use of space, some forms of social use of space emit more light. In particular, employment does seem to emit more light than residential uses of space. And that would be it. If anyone's interested in talking more, please find me during lunch.